Hello friends, in this video we will try to understand what exactly is multi-threading and how it is useful in Java. So now let's try to look up this image and I hope you will follow me. So what happens when we run a particular program? See, our operating system will give so many illustrations of doing the tasks parallelly, that is multitasking or multi-threading, what we call. We can think of copying a file parallelly while we are watching a movie. How can that happen? See, even though we have only one processor, how that one processor is able to do multiple tasks at a time? So the similar concepts we are trying to understand in programming. Within a program, we can make two or more parts of a program to run simultaneously. Even though we say we have got one processor, an illusion can be created in such a way that any user will feel that two parts of a program are running simultaneously. For example, by default, as you can see in this image, every time whenever your program runs or your operating system starts, we have got a main thread running. So now we have to understand what is this thread terminology. Thread is a separate stream of execution. Suppose we say a particular program, if particular program is being executed, then that particular program occupying the space in the RAM, that is primary memory, will be utilizing some resources for its execution. Thread means each and everything used by a particular program in order to give its output. For example, let's try to understand this particular program. So suppose now I have from line number 11 to line number 28, or for this entire program, let's say it is having approximately, it is spanning for 28 lines. So we should imagine that this program is being broken down into two parts, and these two parts are executing simultaneously. Okay, so that becomes multi-threading. So now through this program we will try to understand a thread first. We will try to understand one thread, and then we will try to understand how two or more threads can execute simultaneously. By default, whenever we run our program at the very beginning, by default one thread always runs, that is called as main. So when I say main, you should imagine a series of instructions occupying some resources in my computer in order to do its particular job. So that becomes my thread. So we are talking about one complete stream of execution. It takes its input from the keyboard, it may be trying to access the monitor to display its output, it may be consuming some CPU cycles for its execution, and so on. So by default, whenever a program runs, we have got the main thread running, and each and every thread in our program is associated with a group. A group may be consisting of two or more threads trying to accomplish one complete task. So we have to understand two things. Thread is going to have a name. Right now the name of the thread is main, and it's always associated with a group. Okay, and by default at the very beginning the name of that group is also main. Okay, so in Java, the multi-threading concept, as I have already been telling, Java is all about learning the classes, packages and interfaces, methods and so on. Now what is thread? Thread is a class present in Java. What is thread? Thread is a class. Now T is equals to thread dot current thread. So what does that mean? So let's look at its documentation. So it says current thread. It returns a reference to the currently executing thread object. So what did I say at the very beginning of a program? Whenever a program runs, main thread is at the starting point of its execution. By default, every program will be started by the main thread. Now let's try to know some more information about that particular thread. So whenever we say thread is associated with a group and thread is having its name. Currently that reference of that particular thread is being assigned to T. So now if I run this program, it should display the first line of output as current thread followed by some information associated with that particular thread. By default the name of the thread is main, but by using the method setName we can make this current thread to be renamed as myThread. Okay, after changing the name, here the name of the thread will be main, but here the name of the thread will be myThread. Now we have already gone through the try catch block, right? So we know the exception handling. So now I am trying to include this for loop within the try block. So now I have got int n equals to 5, n greater than 0, n minus minus, some loop decrementing the value of n. It's going to display the value of n. What is the value of n at the very beginning? N is 5. Thread dot sleep. What your sleep method on a thread is going to do is, it is going to suspend the current thread for this number of milliseconds, that is 1 second. That is for 1 second. So what's going to happen now is, whenever we run a program, everything executes in a fraction of a second and we get its output. But now in this program what we are going to do is, we are going to make this current program to sleep for 1 second every time whenever this for loop runs. That means after displaying n equals to 5, the current thread, that is my thread, is going to stop, halt, pause for 1 second, and then once again it starts its execution, displays 4, it stops for a second, again it displays 3, stops for a second, and so on. This is how we can make, or we can control the current execution environment. For example, let's try to run this one. Now as you can see, 5 1 second halt, 3 1 second halt, 2 1 second halt, and so on. What you can notice here is that the name of the thread is main. 5 actually is set as priority. We will talk about priority in upcoming classes. Whenever a thread is created, by default its priority is set to 5, and the first parameter what we are going to see here is the name of the thread, that is main. 5 is the priority and main is the group name of that particular thread with which it is associated. Now here we have changed the name, that is t dot set name. T dot set name is going to change this thread's name. Now very similarly, once we change this name to my thread, the name of the thread is changed to from, so here you can see main to my thread. We have not altered the priority or we have not altered the group, so priority and group remains the same thing. Now what happened here in this for loop? The current thread, that means the current program being executed, is being halted for a second every time this for loop iterates. So what is happening here? What did I tell you at the beginning? How do I define a thread? A thread is nothing but a separate stream of execution. If I am having 3 threads, there are 3 separate streams of execution. In this part of execution, what I am trying to do is I am going to halt or stop or pause or suspend this current execution for 1 second every time by calling this sleep method on this particular thread class. Okay. Once again we'll try to run this particular code. As you can see, after displaying each and every number, it is halting for a second and it is executing after that 1 second. So this is fully variable, my dear friends. So if I change it to 3, now instead of waiting for 1 second, now current execution is going to halt for 3 seconds, which we can easily notice. 5, we have got 3 seconds. 4, 1, 2, 3 3 1 2 3 2. Once again 3 seconds, here 1 is displayed. So what we are trying to do here is we are trying to have a control over this particular execution. So this is called as one thread. Now learning multi-threading is nothing but, suppose if we are having two different parts of the program, we can make the two different parts of the program execute simultaneously. As you can see here, we halted this current execution for 3 seconds. When this thread is sleeping for 3 seconds, that sleep time can be utilized by another thread for its execution. So in this way this multi-threading is achieved. Usually we cannot make this different parts of the program to execute simultaneously, but this is the illusion created by multi-threading, which makes us feel that it is being executed simultaneously. Now this is one thread. This is a single thread execution I have explained in this program, but Java has got multiple methods to make your program to execute simultaneously. Among that, we have got one technique called as implementing the runnable interface. One way is implementing the runnable interface, or else another method is by extending the thread class. See, we have already seen what an interface can do in the previous classes. So if you want your program to be executed, different parts of the program to be executed simultaneously, we can make that by using this runnable interface, or else we can make our program to extend the thread class to run simultaneously. There are two ways. There are two ways of making your multi-threading. One by using this runnable interface. Okay. If we implement runnable interface, our program can do multi-threading. If we can extend thread class, our program can do multi-threading. So now both these two techniques will be explained one by one. Now let's look at that beginning part. So in this first example, what I am trying to do here is, this is the new thread class, the user defined class. Now it is trying to implement runnable. So now, as I explained in the last program, there are two ways. One is to implement runnable and another one is to extend a thread class. Now we are seeing an example of implementing the runnable. Okay. Now we will come to this from the main method. So that's how we are going to execute or understand every program. So class thread demo. Now we have got main method. Now here we are trying to initialize or to start new thread. What is new thread? New thread is the name of the class which is going to do the multi-threading. When we do new thread, automatically control jumps to this part of my program. Now in the new thread, as you can see, it's the constructor. Okay, it's the constructor, so we need not have a separate object to create it. So I hope you can understand that one. Now t equals to new thread. So what is this t? T is the object to the class thread. What is thread? Thread is a built-in class available in Java, my dear friends. Okay, t equal to new thread. This demo thread, what is this demo thread is going to do? There is a constructor inside the thread class which is going to accept two parameters. One is the object, that is this, and another one is a string which will be renamed for this particular current thread. Okay. Now when we run this program, automatically main program starts its execution. Whenever we create another thread, every such thread will become the children of main thread. Now this is the first child thread we are going to create, and now by default we are going to create, or we are going to invoke start method. So this is as per the rules of Java. Okay, every thread, if you want a thread to run parallelly, you must call a start method on that particular object. this start method in turn automatically calls run method. I repeat it again. When we create a thread, when we rename it, the initialization is done here. If you want your thread to run, then you need to call start method. Once you call the start method, this start method automatically calls run method. Okay, so here we have the run method. Okay, so now let's try to understand this execution. Now when I say new thread, all these things will happen. That is, a thread is being renamed as demo thread, child thread is printed, and start method is invoked. As you can see, start method, invocation of start method ends new thread's execution. That is new thread method's execution. Now right now, once this new thread method execution is over, as I said, tstart is going to automatically call run, but new thread is over right now. Now this once again hands over the control to the main thread. Now once again we come here to try block. In this try block, as we have seen in the last example, here I am trying to display the main thread, and then I am going to make this thread to sleep for 1 second. When this main thread sleeps, automatically your child thread starts its execution. Once again this child thread starts its execution, it sleeps for half a second, that is 0.5 seconds. When it sleeps for 0.5 seconds, now once again main thread starts its execution. It executes and then it sleeps for 1 second. While it is sleeping for 1 second, once again your child thread starts its execution. So in this way, while you are executing this part of the program, simultaneously what we can do is we can make this part of the program also to run. As you can see, the simultaneously word is very ambiguous here. We are not talking about two parts of the program running very parallelly, but their execution is halted for a while so as to make the way for another part of the execution to continue. That is the fundamental thing here. Okay, once we run this program, you will try to understand. See, main thread is there. So as you can see, once main thread is executing, it stops for 1 second. While it stops, child thread starts its execution. Now child thread, as you can see here, for what time it sleeps? It sleeps for half a second. But main thread is sleeping for 1 second. So 2 half seconds make 1 full second. That's why if we can see, when one main thread stops for 1 second, 2 child threads execution we can see. Because main thread stops for 1 second, child thread halts for 2 half seconds. So similarly, what we can see is, we can see 2 different parts of the program running simultaneously. Okay, now I hope you have understood this run execution, and we have executed this particular main method's sleep execution. Now, since main method is the primary method which is automatically created by your Java runtime environment, every other thread we create through this program will become children threads of, or child of, the main thread. We have to ensure that every child thread stops or finishes its execution before main thread ends. Okay, main thread is just like a mother thread. This mother thread or main thread is expected to end at the very end. Okay, that's why by the time your program reaches this 46th line, all the children threads have finished their job. At the very end, your main method is executed. Another thing what we can notice here is every time we are including this multi-threading example with try catch block. Once we do this, any other interruptions from operating system or any other parallel execution of the program which is trying to disrupt the multi-threading concept will result in interrupted exception condition. So this multi-threading concept can be interrupted. If it is interrupted, then interrupted execution, interrupted exception is called by the JRE, and then it is caught by this catch block. Okay. Once your children finishes its execution, or once your child finishes execution, exiting child thread is printed. So now where do we see that? Here, exiting child thread. So child thread 54321. So child thread execution is finished. Once that entire for loop is finished, your child thread execution is finished. So now it will result in terminating of your main thread. Okay. So this is one fundamental of your multi-threading. See, multi-threading doesn't mean, as I have been repeating from the beginning of this class, practically speaking, we cannot make two parts to run simultaneously. Okay. So what we are trying to refer here, that is switching from one part of the program to another part of the program. So I am using the term switching here. That means one halts, another one begins. When the second one stops, another one starts. So the starting and stopping in between is a very synchronized manner of executing the program. So the starting, stopping the thread, making it to sleep for 1 second, making it to start after half a second. See, everything your OS and your JRE is going to take care of it, mainly the JRE. The only thing we need to understand here is what are the methods I have within this program to make a program run, start, sleep. In this multi-threading concept, we learn mainly 3 methods here. The first method is start. Okay, the life cycle of that particular thread itself starts from the start method. This start automatically calls run. See, in this entire program we don't have a programmer's invocation of run method. It is automatically called by this start. So that's how your theory of multi-threading goes. And then if you want to make your program to sleep, then you can call this a sleep method. So I'll just show you what happens if we don't make this sleep. So it says demo thread uncompilable source code. The Java interrupted exception is never thrown because interruption will happen if and only if we make this program to sleep. Okay, so that's why this entire concept is learned using this start, run and sleep. So suppose if I vary this to 100, see what will happen. By the time your main thread here sleeps for 1 second, we have got 100 milliseconds. So 100 millisecond into 10 will constitute 1 full second. So while it is sleeping for 1 full second, this child will complete its execution, and then we can see by the time main thread prints 2, all this children will finish its execution, this printing of 54321, and then your main thread ends, as we can see here. This is the simple example of your multi-threading. So this is one method what we can use using this implements runnable. Runnable is an interface which has got methods like start, run, sleep and so on. We are just trying to implement them. Now let's go to new thread. So this is the second way of understanding the thread. In the last class, what we did, we implemented runnable. Now in the last program we implemented runnable. Very similarly, now we are trying to understand how we can do this using the extending the thread. So now let's start from main method. Where are we? Here. Okay, so here in this program we are trying to extend this particular class using the thread, and most of the other part is very similar. Let's try to understand that one. So here we are calling this constructor, that is new thread 1. So when we do new thread 1 constructor is invoked, super demo thread. So now here, since this new thread 1 is extending this thread, we are making this super usage to send demo string to threads superclass. So this will make the threads superclass to receive this demo thread superclass to receive this demo thread and set the name as demo thread. Okay, now we have got this start method. Now once we have this start method in turn invokes run method. Okay, so now we'll come to try block. So here for loop out.println main thread, after printing main thread file, thread sleeps for 1 second. Once thread sleeps for 1 second, by the time the main thread sleeps, your run method will start its execution. Your run method will make the child thread to execute twice. That is, it's going to sleep for half a second and then once again it's going to start after a half a second. In this way, by the time your main thread sleeps for 1 second, your child thread executes twice. So I hope this can be followed. If we have followed the last example, we are seeing one main thread, two children thread, one main thread, two children thread, and so on. The thing is, this is a very recurring important question in the examination. That is, how can we make a class threadable? We can make it either extending the thread class, or else we can make it either by implementing the runnable interface. In the upcoming class, we will see how we can alter the priority of a thread, how we can do the multi-threading, how we can have more than 2 threads, more than 2 children threads, and so on. Thank you for joining in this class. So follow this class to understand the further classes. Thank you.